Good morning, everyone. Today I will be presenting a solution for the ArangoDB Hackathon. My name is Samarth Sareen, and my teammates are Lovepreet Singh and Bhaskarji Sarma. Our team name is Team Pulsegraph. We all work as a data scientist in a US-based financial firm, and we are here to present our solution today. So to start with, why we participated in this hackathon. So our participation in this hackathon was fueled by our passion for innovation and other commitment to solving real-world challenges at intersection of technology and finance. As someone currently working at a financial organization, we understand the first-hand critical need of timely, actionable insights to drive effective decision making in the financial world. This application can be solved in the following use cases. Proactive risk management. So, in finance, early detection of global events such as geopolitical tension, economic shifts, or emerging crises is a vital indicator for mitigating risk. By leveraging the GDELT dataset, real-time global news monitoring, we can capture and analyze signals that might indicate market volatility and systematic risk before they fully materialize. The detailed sentiment analysis and event taxonomy provided by GDELT empower us to track what is happening around the globe and how these events are perceived. This nuanced perspective can be instrumental in shaping investment strategies, identifying emerging market opportunities, or foresee downturns in specific regions. The third point being an innovative use of graph analytics. By using OrangoDB's graph analytics to structure and analyze the interconnected data from GDELT, we can reveal patterns and relationships that are not immediately apparent through traditional data analysis. This approach aligns with evolving needs in financial sector where understanding complex relationship, be it geopolitical events, market movements, or investor sentiment can provide a competitive edge. These are some impactful use cases from a financial world which can not only be solved using knowledge graph and LLMs. We participated in this hackathon to showcase real-world impact and demonstrate how combining open source datasets with advanced analytics can drive innovations that are not just theoretically impressive but also practically valuable, especially for high-stakes environment like financial industry. Moving on to the problem statement. So everyday news outlets worldwide publish news reports on conflicts, crises, and significant events. Critical information is often lost in this data. For instance, early signs of social unrest and emerging health crises may go unnoticed until it's too late. Manual monitoring cannot keep up to date with the sheer volume and the velocity of the global news. This lack of timely insights can lead to delayed responses, missed opportunities, or unchecked escalations of crisis. Our application tackles this problem by automatically monitoring and analyzing real-world events in real time, distilling actionable insights from worldwide news. The goal is to improve the global situational awareness and decision making. Moving on to the selection of dataset, we chose GDELT dataset for its strengths that align perfectly with our application needs and approach. The first point being real-time global coverage. So GDELT monitor news media across over 100 languages and multiple countries, updating continuously with new and updated events. This ensures our application is fed with information from all corners of the world, not just English or Western sources, providing a truly global perspective. Having a built-in sentiment analysis, the dataset doesn't only catalog events, but it also captures the sentiment of how each event is reported, especially measuring how the world is feeling about what's happening. This is very important for our application as we can gauge public sentiment or tension around an issue. For example, a protest may be portrayed positively or ambiguously in real time. By incorporating this sentiment signal, our tool accesses not only what's happening but also the emotional and the social impact of these events. Third point is comprehensive event taxonomy. GDELT classified event into 300 categories ranging from peaceful interactions to violent conflicts. This rich taxonomy means our application can distinguish between different types of events, for example, differentiating a diplomatic exchange from a protest or a humanitarian crisis. With this granularity, we derive more nuanced geopolitical insights, such as identifying spikes in a specific event types or tackling how a certain kind of events evolve. Geopolitical and geographical context. Every G-Delt event is tied of locations and actors, like countries, organizations, and individuals, enabling deep geopolitical analysis. The data provides attributes like geopolitical coordinates, actor information, so our application can map events on a world map and filter by region or actor. We can highlight, for instance, hotspots of unrest or trace the spread of an issue across borders. This context helps users immediately grasp where and who is involved in developing story, making the insights far more actionable. The graph data of GDELT essentially weaves all these entities and events into a massive interconnected graph. It connects every person, organization, location, etc., and event across the planet into a single massive network graph, capturing global activity and context. We leverage this structure by treating the data as a network of nodes and edges. For example, in an application, key entities like organization and countries are nodes, and event linking between them becomes an edge. This graph-based approach lets us uncover patterns that isolated events might miss, such as identifying a central influencer that appears in many related events or discovering clusters, communities of related incidents through shared participants by location. By using GDELT's network data, our solution can connect the dots between disparate news and reveal the bigger picture. By using an open, well-established dataset like GDELT, we also ensured our project is built on a reliable and scalable foundation. Rather than a narrow and a proprietary data source, GDELT's breadth and openness allowed us to focus on innovation, building an analysis, visualization, and instead of spending time on collecting on and licensing the data. So now I'll walk you through the code and the approach which we have used. So here I am importing all the libraries. We are using NetworkX and NetworkX ArangoDB. Then we are using LangGraph, LangChain for the orchestration framework. We also have leveraged Langsmith to trace all the LLM's call and have more insights of the LLM interactions. We have also used Ragast as a part of evaluation matrix, which I will be showing in the next and the upcoming code pieces. So the first we are just initializing Langsmith. We are also using mem0 as a memory component for our application, which is responsible for saving all the interactions and the user queries along with the responses. Post that, we have initialized the RangoDB client and based on the username and password. We have then leveraged the Open Intelligence dataset and converted into a Q graph. Then we have initialized the LLM. We have first, this is the first tool which we have used. This tool is responsible for converting the user query into a AQL code and then converting that back into a natural language which will be shown to the user. The next tool we have is conversion of text into a NetworkX algorithm. So this tool is basically responsible for converting the user query into any of the NetworkX algorithms. So we have used couple of approaches in this. So the first part is basically a Python code generation based on the user query. This code is responsible for generating the network X Python code based and including the matrix which it thinks should be the right matrix to answer the user query. Post that we have added a reflection step. So this reflection part is responsible for checking the Python code which has been generated and is it in line with the user query. So if somebody has asked about degree centrality, does the Python code also work in lines with calculation of degree centrality? This is the reflection step. If it doesn't, then this step is responsible for creating a new Python code. Post that, we try to execute this Python code which comes out of the reflection step. If there is no change required, then the reflection step won't make any changes in the Python code. Then we try to execute the Python code. If the Python code gets executed without any errors, then we just pass on from this step. If there is an error, then we again pass it to a reflection piece which is responsible for rectifying the error which has been generated in the previous execution. So in this prompt, we pass in the Python code along with the error which has been generated for the LLM to fix the error and generate a new code. This will happen at least 3 times before it raises an error. Post that, we pass in the final result of the Python code for the final LLM call to generate the answer. Here is the part where we are uh, defining the evaluation of the AQL. So we have added evaluation only in the AQL step. So for the queries where the tool thinks or the agent thinks that the AQL tool should be called, then in that case we try to calculate the faithfulness and the answer relevancy. So for that, what we do is we take the results which have been fetched from the AQL along with the answer which has been generated, and we pass both of them into the Ragas framework for calculating the faithfulness and answer relevancy, and then we show the result along with the final answer. But this, please note that this step only happens if we are doing it through the if the tool called is the AQL query tool and not the network X Python code tool. We then create a React agent, and then we pass in the first query, which is which we ask which is the most influential node in the graph. So according to this, the Python the tool thinks that the network X tool should be called, and for that influential node, it has calculated degree centrality. Then it goes into the reflection part. So what has happened is that in the first code which was generated, it has executed a dbaql execute query as well, which is fetching only all the events, whereas the the reflection part thinks that there is no requirement of that filtering, so it removes that and then only the degree centrality is calculated. And we have the final result as class battles. We will run this step to generate and save save the generated response and the user query into mem0. This has been saved, and if I take you to mem0 and I show you the the new entry which has been made, so you can see less than an hour ago, Summers, which is me, has entered a user query which is the most influential node, and assistant has responded with this following answer. Also, if I go into LangChain, if I go into Langsmith, then you will see the following traces of the complete call which has been done. So it shows which tool has been called, what was the query all about, and what was the final answer. Then if I run the next query, which is what happened on 25th 2020 in the graph. So this is the AQL query which it has generated, and then it has shown the results as well. In the next step, it is evaluating the results using the Ragas framework. And in the final answer, you will see that we have the faithfulness score as well as the answer relevancy. Again, I will pass it into mem0. Then I can run the next query, which is asking about which node in the graph has the highest eigenvector centrality. Again, if you see, it has executed the filtering part, which is not required. So in the reflection, it has been removed. But while executing it showed an error of power iteration failure conversion. So for that rectification, it has added a new parameter of max iteration, which is of 1000, because initially by default it is 100, so it showed an error. But it was fixed after the next reflection step, which we showed above. Again, putting it the mem0. So then I run the final query, next query of, is there any news which happened on 20th of March? So it has pulling all the required information for 20th of March. Again, it's a AQL query. Then, so it's running the evaluation. So in this evaluation also, both faithfulness and answer relevancy will be executed. And here you can see the faithfulness score is 1, which is like highly faithful, and when again we have the answer relevancy. I will be skipping the mem0 part over here, and then I will be running another query of getting the highest page rank node and value. So again it has executed the page rank, and we have the page rank highest node with page rank and what is the value. So these are some more queries which I'll run on real time to show you how fast the responses are.